Hey everybody, this is Mrs. Costello. I'm doing day 3. We're going to do some Pascal's triangle, doing some more combinations, and we're using it with the binomial theorem. So the first thing we're going to talk about today is Pascal's triangle. So Pascal's triangle is a really useful way to represent some number patterns. That's basically its main definition. It's a way to represent how numbers work, and we can use it a lot in probability. So it's going to be, for us today, our main focus is it's another way to predict combination or to find combinations. Okay. And we are also going to help us when we are multiplying binomials with a degree bigger than 2. Okay, so that would be another way. It can be helpful with multiplying binomials. Okay, so Pascal's triangle as combinations kind of looks like right below where it says as combinations, and we've seen this notation before. This is like that, 0 choose 0, 1 choose 0, 1 choose 1. We've seen this. This is kind of how it flows in general, and we're going to kind of talk about that. As numbers, though, this is going to be our biggest focus today. So as numbers, the very top is always a 1. This is like your 0 row. Your second row is always 2 ones, 1, 1. And then from there, you kind of build the rest of the rows. They will always start and end with 1, and then they'll be the sum of the numbers above them. So I'll start my row with a 1. The next number would be 1 plus 1, which is 2, and I'll end with a 1, like that. The next row, I'll start with a 1. 1 plus 2 is 3. 2 plus 1 is another 3, and another 1. Now, it's always going to look like this. So throughout the video, I might make a really quick Pascal's triangle. But this is how it always is. 1 plus 3 is 4. 3 plus 3 is 6. 3 plus 1 is another 4, and I'll end with another 1. And I'm just going to go up to 5 because you can go as far as you want, but 5 is kind of the sweet spot. So 5, 10, 5, 10, 10, not 5. My bad. 5 and end in a 1. Okay, so like I just said, the first and last numbers of the row are 1, and then every other number, that is the sum of the numbers that are directly above it. So there you have it. So we're going to kind of build our Pascal's triangle to do the combinations. You can always still do your, 5 choose 3 or whatever, but we're going to just kind of try it on this one. So on number 1, out of 5 finalists, your class must choose 3 representatives. How many combinations of students can be chosen? So obviously we learned in day 2, we could do 5 and then that choose 3 function in your calculator, or if we really wanted to, now we could use Pascal's triangle. So we could make our triangle, and we're going to go to row 5. So I need to go to row 5. Remember this first row? This is the 0 row. So here's row 1. 1, 1, 1, 2, 1, 1, 3, 3, 1, right? 1, 4, 6, 4, 1. And now we're on row 5. 1, 5, 10, 10, 5, 1. So when you do this, like I said, we are looking at row 5, and then you go 3 spaces. So 3 spaces. Now the 1 does not count. So I am not going to start here. I am actually going to start at this 5 where I just did rainbow pen, and I'm going to count 3 spaces. 1, 2, 3, 10. If I really wanted to, in my calculator, I could still put 5 choose 3, and guess what? I would still get 10. But if you don't have your calculator, you could always do it this way. Okay. Number 2, Melville has 8 stuffed animals. in her collection, how many different ways can she select 3 animals? Okay. Again, this is like what we did the other day where we have 8. We are going to choose 3. So 8 choose 3. So I need to make 8 rows. So 1, there's my 0 row. 1, 1, there's my first row. 1, 2, 1. You get really fast at this as you go on, especially like the first 5. 1, 3, 3, 1. 1, 4, 6, 4, 1. 1, 5, 10, 10, 5, 1. Okay, 1, 6, 15, 20, 15, 6, and 1. Remember, I'm just adding the ones above it. I'm going to run out of room. 1, 7, 6 and 15 is 21. 15 and 20 is 35. 20 and 15 again, another 35. 15 and 6 is 21. 6 and 1 is 7, and in a 1. Last row, and this is the only row that we care about. 1 plus 7 is 8. 7 plus 21 is 28. 21 and 35 is 56. 35 and 35 is 70. 35 and 21 is another 56. 21 and 7 is 28. And 7 and 1 is 8. All right, now I made my 8th row, and I know by now you're like, dude, I already found it in my calculator. I get it. We can always check it, though. So remember that the 1 does not count. We have to start from the 8, and we need to go 3 spots. So 1, 2, 3. 56 would be the number of ways that she can rearrange her 3 animals. Again, if you want to put that in your calculator as this, 8 choose 3, guess what? You'll still get 56. This is just another way of doing this. So, binomial theorem. This is actually going to be really helpful. The Pascal's triangle is going to be really helpful if we're trying to multiply binomials that have a power greater than 1. So like if you, instead of writing out like 3 of those binomials and then foiling that many times, you can use this, which is really, really nice. And I know that this looks super confusing. So what we're going to do is you have to use the Pascal's triangle as your coefficient. So Pascal's equals the coefficients, and I'll help you with that. In your binomials, instead of writing it out this many times, what you can do is you can do a to a descending power. So you would start like with whatever your power is and then go down. So decrease power. And then your b actually increases power. And we'll kind of talk about that too. Perfect. All right. So for the first 3 of these, we're going to use, first we have to figure out like our Pascal's coefficient. So the power determines what row in Pascal's triangle you're looking at. So if I'm looking at the first one, 3, I have x plus 4 cubed. So I'm looking at row 3 in Pascal's triangle. Okay, row 3, I mean, I can just go up to the problem I just did. Row 3 is right here, 1, 3, 3, 1. Okay, 1, 3, 3, 1. These are going to be my coefficients of each part. So if you want to go ahead and write out 1, leave some space because we have some stuff to put, 3, 3, 1, you totally can. Those are going to be the coefficients. Then this is my A and this is my B. So we are going to start with whatever power we're at. So if we're starting with cubed, A is going to get the cubed on my first term. So 1 times A is x, right? X cubed times, now we always start at 0 for our B. So 4 to the 0 plus. Now we're just going to kind of fill it in. And we're going to decrease the first power and increase the second power until we get down to 0 for that first one. So decrease, so this is now x squared, and times, we're going to increase the 4, so 4 to the first. Okay. Plus again, let's see, decrease x to the first, increase the 4, so 4 squared. Oh, sorry, got kind of tight right there. Plus our last one, x is now x to the 0, and 4 is now 4 to the third. Again, this is instead of writing out x plus 4 3 times and foiling it out. So, right here, 1 times x cubed, well, x cubed is just x cubed. This 4 to the 0 is just 1, so that would be my term. I'm good. Plus 3 times, let's see, x squared, and 4 to the first is just 4, so 3 times 4 is 12, x squared. 3 times 4 squared, well, 4 squared is 16, so 3 times 4 is, 3 times 16 is 48, 1x, because it's just x to the first, and x to the 0, so no x on this one, but 1 times 4 cubed. Well, 4 cubed is 64. Again, I would get that if I decided to like write out x plus 4 3 times and FOIL, but this is just another way of multiplying out those binomials if we really wanted to. Okay. Same thing on 4. So we are looking at the 4th row of Pascal's. So the 4th row, I'm just going to give it to you, is 1, 4, 6, 4, 1. All right, so those are going to be our coefficients. So if you want to go ahead and write them out, 1, 4, 6, 4, 1. Ooh, I didn't leave myself enough room. That's okay. All right, 1, 4, 6, 4, 1. Then let's look at our A and our B. So this time we have to be a little careful because we have a negative on that n. So we just need to kind of think about like, okay, when is this going to be negative? When is it going to be positive? So our A, remember our A starts with our highest exponent, which is 4. So I'm going to put 2m to the 4th times our B starts with the lowest, which is 0. So negative n to the 0 plus 4 times decrease the next one. So 2m to the 3rd, increase the second one. So negative n to the 1st plus decrease again, 2m squared times increase the second one, negative n squared plus, sorry, I ran out of room again. Sorry, guys. 4 decrease, so 2m to the 1st times increase, so negative n cubed plus, sorry, the coefficients are really messing me up. Decrease the 2m, so 2m to the 0 and negative n to the 4th. All right, we got a long ways to go. So, right here, 2m to the 4th. So remember that both things get the 4th. So 2 to the 4th is 16. M to the 4th is m to the 4th. And we don't have an n. We don't really have a 1. That part's not important on this first term. 2m cubed. 2 cubed is 8. 8 times 4 is 32. So that's my coefficient. And then, we got to be careful. My bad. Look at our n. Our n is n to the negative 1. So that means I'm actually going to have a negative 32. And then m cubed, n to the 1st. Kind of weird with 2 letters. And then second term, 2m squared. So 2 squared is 4. Times that 6. And I know my n is going to be a positive because it's squared. So 4 times 6 is 24. So I have a 24 here. M squared and n squared. Okay. Next part, let's see. That n is going to be negative because I have a cube. So I'm going to go ahead and put a negative sign out there. 2 to the 1st is 2 times 4 is 8. So minus 8. M to the 1st, n to the 3rd. And then the last one, I don't have to worry about this because it's gone. So plus, and then just n to the 4th. Okay. Again, very long, but still shorter than like if I decided to FOIL it out. You know what I'm saying? All right. Why don't you guys go ahead and do number 5 on your own? when you finish number 5, you can unpause your video and you can see my work. So go ahead and pause your video and do number 5. All right, guys, here's my work on numbers 5. I got a cubed minus 6a squared b plus 12ab squared minus 3b cubed. So again, one thing that you could do that I didn't really mention earlier is you could always check that your exponents are decreasing on your a's and increasing on your b's as you go down the equation left to right, which is exactly what mine are doing. So yay, we're good to go. All right, we got 2 more things to do. Now, when we're doing this, it wants us to find the coefficient of a given term in the binomial expression. So when we do this, yes, we could use some Pascal's triangle, but these numbers are going to be really, really, really big. Like my first one has an exponent of 9. I honestly don't really want to write out all 9 rows. So how could we get our coefficient, how could we get our coefficient from 9? Because I know that we could totally set it up to do our binomial theorem. If you think about this, like I need the x to the 5th term. So if you think about it, x to the 5th, it means like I'm going to start with this x right here. So I'm going to start with x to the 9th, 8th, 7th, 6th, 5. So this guy right here, right? The 5th one. And then I am going to increase my second one. That's just going to help me, right? So my a would be at 5. So 2x to the 5th. The a would be increasing. So we would start at 0. 1, 2, 3, 4. There we go. So the b, which is the negative 7, would be raised to the power of 4 because that's where it's at. Now, how do we get our coefficient without making Pascal's triangle? Well, remember that your Pascal's triangle is actually like, you could do it in your choose, right? You could do a factorial if you want. I'm going to do like 9 choose whatever. So this is your first 9 choose, and then this is your second, because that would be your position anyways. So I'm going to write 9 choose 5, okay? And I'm going to do that first in my calculator because that. So go into math. We're in probability. I know mine looks a little different than yours. I know you have to put that 9 in first. This is what mine looks like. It's a little different. The top number is going to be my 9, and then my bottom number is going to be my 5. 9 choose 5. 126. So 126 would be the coefficient. So 126 goes right here. And then I'm going to multiply it by whatever I get right here. So I have to do 2 to the 5th. Well, I know 2 to the 5th is 32. X to the 5th is just x to the 5th. And then negative 7 to the 4th. That is a huge number. It is I already put it in my calculator earlier. It's going to be 2,401. Yikes. Okay. So really, really, really big number right here because we have to do 126 times 32 times 2,401. Oh my gosh. And that's going to be our coefficient. I already have 126 in there. So I would do 126 times 32. Not divide. Oops, hold on. Times. There we go. 2,401. Equal. That is a huge, huge, huge number. But that is what I get for my coefficient. So, yeah. So let's go. So 9,680,832. And I don't think you would have wanted to do your whole binomial expansion just to find that. So that's how we would find it without using the binomial expansion. We'll do one more and I'll do this one with you. Don't worry. So find the coefficient of the x to the 8th term in your expansion of 3x plus 2 to the power of 10. So I'm already starting to label some of these things. So this just means that this is my, the 10 means that's my highest power. I want the 8th term. So let's go ahead and start, 10, 9, 8. So really I'm only going 3 in. Right? 1 or 0, 1, 2. The other thing is make sure that these guys add up to whatever your power is when you're doing these. So they do, so I'm good to go. Let's go ahead and do my coefficient. So 10 choose 8. 10 choose 8. And I am going to do the eighth power of my a. So 3x to the power of 8 plus the second power of my second term. That one's easy, just 2 to the second. That's not bad. All right, let's go ahead and see what that 10 choose 8 is. Calculator. Math probability. Gonna do 10 choose 8. 45. And that would make sense because like it's not gonna be super far down. So 45 is gonna be my coefficient right here from my Pascals. And then 3 to the 8th. Well, I gotta do the math on that one. Okay, 3 to the 8th is 6,561. If you want the x to the 8th there because it makes you feel better, you absolutely can, but really we care about the coefficient. And then, I don't know why I put a plus there. I'm sorry, that's a times. Times 2 squared is just 4. So all I have to do next is multiply, 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 and get a really, really big number. So we'll go ahead and do that. So 45 times 61 times 4 is 1,180,980. That would be the coefficient on that x to the 8th term. That's a pretty big one. So, all right, that's all I got for you today. So if you have any questions, make sure you ask your teacher tomorrow in class. Otherwise, enjoy the rest of your day.